Twitter and GitHub, Gmail, all those other places. I list this stuff because I encourage you to reach out and provide feedback or ask questions. If you're going back over this stuff, particularly the stuff that we'll be going through the course of this workshop. And there's a lot of depth here, especially as we get further into it. The exercises become extremely challenging. There are exercises that took me weeks to work out, and then I'm expecting you to do them in like 20 minutes. So they're extremely challenging on purpose. It's trying to push your understanding of asynchronous patterns. So if you have questions about that, or if you're struggling with that, please feel free to reach out. Love to help you with that. Just real quickly, I've done several open source projects, Lab.js, Script Loader, Grips is a templating engine, Asequence. We're going to spend a lot of time talking about Asequence actually, but not because I'm trying to sell you on that library, simply because it is designed to help make asynchronous programming concepts easier to understand and manage in your brain. It's designed to make them easier to teach. So you'll get some exposure to Asequence as we go throughout this workshop. I am the head of curriculum for MakerSquare for about the last 3 or 4 months. MakerSquare is a developer engineer training school. We have campuses in Austin, San Francisco, and Los Angeles, and we will be expanding as well. We take you from junior level status to intermediate status, and that's slightly different than other schools, which may say we start you from nothing and get you to junior level status. We're more on the higher end. We like to kind of think of ourselves more like the MIT of these developer schools. So you start out at a higher level. It's more is required of you. But we also take you a lot further. It's a full stack JavaScript school, so we teach all the front end frameworks like the Angulars and Reacts, and all the back end things like Mongo and Node and Express and things like that. If you have any questions or thoughts about tech schooling, or you know somebody that's interested or has some questions, please put them in touch with me. I'd love to chat with you more about that. I've written a series of books on JavaScript called You Don't Know JS. A lot of what we're going to talk about today is covered in some way, shape, or form in those books, particularly the Async and Performance book as well as the ES6 book. You should be able to find quite a bit of coverage of some of these topics in those books. The entire 6-book series, 1,100 pages worth, is available for free online at GitHub. This youdon'tknowjs.com will redirect to that. You can also purchase them. They've been edited and published through O'Reilly, so you can purchase them if you're happy with that content. Today we are going to talk about asynchronous patterns. Now, I want to explain right off the bat that my approach to this, much like my approach to the other things that I teach, is to first focus on the concept before explaining the how to use something. That differs from some of my peers who would present to you the API for something, and then maybe perhaps later you might pick up on some of the conceptuals behind it. I think it's more effective for you to understand why you do something a certain way before actually getting too immersed in the actual doing of the thing. So, for example, some of you listening probably are already at least somewhat familiar with promises, but I'm not sure everyone has had a very good conceptual grounding in what a promise really is and why a promise is useful. Because I see an awful lot of arguing about promises in the open source community, and they seem to focus an awful lot on bickering about the API for promises and missing out on the deeper point of why they even exist. So for each of the topics that we're going to go through today, our goal is to build up a conceptual understanding first, and then a practice of why we do the thing, of doing the thing once we know why we do it. So we're going to actually start, even before we talk with some code, we're going to start understanding a very important distinction that is often conflated. We're going to look at the notion of parallelism versus asynchronicity. This is really speaking to the idea of concurrency. So we're actually going to dig into what concurrency really means, specifically what it means to a JavaScript developer, because that is the motivation by which we do all the rest of the things. Then we're going to turn our attention to callbacks, the most fundamental premise of all of, the fundamental unit of asynchronous programming. And what we're really going to see is that callbacks, while capable of expressing everything that we need, have some very significant deficiencies. 2 major deficiencies, in fact, that I would use to define the notion of callback hell. Callback hell is thrown around an awful lot, and most people, when I say that term, what evokes in their mind is that it has something to do with indentation, with nesting, things like that. What I'm going to show you is that callback hell has actually almost nothing to do with indentation and nesting. There's something much deeper, much more important to understand about callback hell. So we're going to look at callbacks and look at why how they work first. We'll get some practice with them, just to understand that, kind of some first-person experience with the pain of that. I'm sure you all have that already. But then we're going to look at what those problems are, give them a name, give the problems of callback hell a name. And we're going to look, and that will be our motivation to why we want to try to solve those problems with these higher order patterns. Another variation on callbacks that we're going to look at, which is kind of interesting, it has not gotten a lot of attention. Many of you may not have even heard before, but thunks. Thunks are something that I even just sort of recently myself, and by recently I mean within the last year or two, discovered this pattern and realized, wow, I really wish I hadn't been able to articulate that pattern years ago, because actually it's a really good precursor to understanding what promises are about. So we'll look at thunks and we'll look at why they are part of that tool. They're one of the little tools you should have in your tool set. Having that conceptual understanding of what a thunk really is and what it's useful for, that will bridge us into promises. In other words, thunks are kind of like promises without the fancy API. So once we get the conceptual grounding in thunks, we'll understand why promises are useful. We'll look at the APIs for how to use promises. We'll look at some patterns for them. All along the way, every one of these patterns, we're going to be revisiting an exercise, the exact same exercise over and over and over again. And you're going to re-implement the solution to that exercise using every single one of these patterns, from callbacks all the way up. The goal there being that you will be fully understanding, you don't have to worry about the problem domain anymore, you'll be fully understanding the pros and cons of each of these patterns. So that's how we'll go about it. So we'll be looking at promises. Then we're going to look at generators and coroutines. And by the time we've looked at promises and generators, we actually will have established two solid solutions to those major issues of callback hell. That represents the baseline. The point at which, if you're ready to tune me out and you don't, I've overwhelmed you or you're bored or whatever, you got to get this part. You got to get through the promises and generators. That is the new baseline for competency in asynchronous programming, is understanding what promises are, what generators are, and why the two need to be mixed together to solve the issues of callback hell. That's the new standard for competency. So that's really, if you get nothing else out of the workshop, I want to make sure everybody gets to that point. So we'll spend plenty of time making sure we get to that point. But that's not all, because there's more to asynchronous programming that those patterns aren't necessarily good at. There are more variations. Point that I'm making is, I've written a lot of code in my 17 years in JavaScript. I've never once written an entire program using exactly the same abstraction everywhere. There is no one silver bullet. Anytime somebody starts to tell me something like X is the new Y, my BS radar goes off. I'm like, no, it's probably not. As a matter of fact, it's almost certainly not. There's no one silver bullet that replaces everything else. So nothing that I'm teaching you today is going to be replacing everything else that we've talked about. Rather, you should consider these things, instead of ors, should consider them ands. This is additive. These are additional tools, additional patterns, and you can develop instincts for why one pattern is more well suited for a particular set of problems. My programs try to efficiently use each of these different patterns where necessary. Even things like callbacks and thunks have their place. Promises have their place. Generators have their place. In addition, when we start dealing with event streams, we'll find that promises actually don't really give us a very good solution when we start dealing with event-oriented programming, what I call event reactive or reactive sequences. That also goes by the name of observables. So if you've read anything, there's been a buzz recently. There's quite a bit of information out there about this notion of observables. There's a library from Microsoft called RxJS, one of the most common implementations of the observable pattern. So I'll show you what that pattern's about, why it's useful. We will relate that back to and practice with the expression of observables in the asequence library, because that'll be easier for us to play with without learning a huge library with hundreds of methods. So a very small subsection of that we'll play with in asequence that I call reactive sequences. Does basically the same thing. So that's a higher order pattern that will help us put all the other stuff that we've learned together in interesting ways and solve event-oriented programming, event-oriented asynchronous programming. And finally, the last pattern that we'll look at, very high-level pattern. Hasn't gotten a lot of attention recently, but it's called CSP. It stands for Communicating Sequential Processes. This is not a new concept. Actually, it was invented in the early 60s, and it was developed and thought about by some really, really smart people, way smarter than I am. So there's nothing new that I'm presenting here, no new information that hasn't been talked about for decades. But it almost feels like CSP is on the cusp of a rediscovery, in particular because recently we've seen some more popular or more mainstreamish type languages adopt this model for concurrency. Namely, the Go language uses the CSP model for concurrency, as well as Clojure and ClojureScript. ClojureScript being the bridge that brings Clojure into the JavaScript world in the browser. So more and more people are starting to move into the Go programming language world and into Clojure and ClojureScript, and they're discovering that CSP is this really powerful pattern for managing concurrency. And I have heard people on the observables side, for example, tell me observables are that silver bullet. You can model everything with an observable. Yeah, kind of, maybe. There's some places that it's really good and some places that it's not so good. And then I've heard people say, well, you don't even need promises because you could do everything with a CSP channel. Yeah, okay, but there's places where that's useful and places where it's not. So this is not an all or nothing thing, but CSP is a fundamentally rather undiscovered or rather untalked about sort of pattern. But I'm kind of convinced that it represents kind of the next wave. If the big wave is observables, if that's about to wash over us, the one after it is CSP. So I want us to be aware of those things and understand how all these tools weave together. By the end of this, we'll be working through some rather challenging exercises, trying to push our brains into thinking way beyond just a simple callback. Okay? So that's where we're going with this workshop. If things seem too simple at the beginning, I promise you by the end there'll be plenty to be digging your teeth into.